My dear students, welcome back to our channel. In this video, I will be explaining the MCA second semester subject Operating Systems as prescribed by Osmania University and other universities of Telangana. We will go through the important questions and answers one by one. Let's begin with a quick revision. Unit 5 first important short question is: what are kernel modules in Linux? Kernel modules in Linux are small pieces of code that can be added or removed from the operating system's kernel while it is running. Instead of restarting the computer to update or add features, kernel modules let you make changes on the fly. They help the kernel stay light and flexible because only necessary parts are loaded into memory. For example, device drivers, like for a printer or Wi-Fi card, can be loaded as modules instead of being built permanently into the kernel. Example: if you plug in a new USB device, Linux can load a USB driver module to make it work. Once you unplug it, you can unload the module to save memory. Key takeaway: kernel modules make Linux modular and efficient. They allow easy updates, reduce memory use, and make Linux adaptable for desktops, servers, and even smartphones. Next important short question is: to define interprocess communication, IPC, in Linux. Interprocess communication, IPC, is a way for two or more processes in Linux to exchange data and messages while they are running. Since processes work independently, IPC allows them to coordinate, share information, and work together efficiently. Linux provides several IPC mechanisms, such as pipes, message queues, shared memory, and semaphores, to pass data safely between processes. Example: consider a text editor process saving a file while a backup process monitors changes. IPC can let the backup process know when a file is saved, so it can create a backup immediately. Key takeaway: think of IPC as a communication bridge between processes. It ensures data sharing, synchronization, and smooth multitasking in Linux without conflicts, making the system more efficient. Next important short question is: 3. What is fast user switching in Windows 7? Fast user switching is a feature in Windows 7 that allows multiple users to log into a computer at the same time without closing other users' programs. This means one user can switch to another account quickly while the first user's work remains running in the background. Example: suppose Ravi is working on a Word document and Priya wants to check her emails on the same computer. Using fast user switching, Priya can log into her account without closing Ravi's document. When Ravi logs back in, his work is exactly as he left it. Key takeaway: fast user switching saves time and effort, prevents loss of unsaved work, and is ideal for shared computers at home or office. Think of it as a pause and switch button for user sessions. Next important short question is: 4. List networking features of Windows 7. Windows 7 offers several networking features that make connecting computers, sharing files, and accessing the internet easier and faster. 1. Home group allows easy file and printer sharing between computers on the same home network. Example: sharing photos and printers between family members' PCs. 2. Network and sharing center. Central place to view network status, manage connections, and troubleshoot issues. 3. Improved Wi-Fi management. Connect wireless networks quickly and remember preferred networks. 4. Virtual Private Network (VPN) support. Securely connect to another network over the internet, useful for remote work. 5. File and printer sharing. Share files, folders, and printers with other network users easily. 6. Direct access and remote desktop. Access your computer from anywhere securely and control it remotely. 7. Network location awareness. Automatically applies security settings based on whether you are at home, work, or public places. Key takeaway. Windows 7 makes networking simple, secure, and flexible, whether at home, office, or on the go. Think of it as a hub connecting multiple computers safely. Next important short question is: 5. What is the role of the programmer interface in Windows 7? Role of the programmer interface in Windows 7. The programmer interface in Windows 7 is a set of tools, functions, and libraries that allows programmers to write software that can interact with the operating system. It acts as a bridge between applications and the Windows 7 kernel, enabling programs to perform tasks like file handling, memory management, and device communication without dealing with complex hardware details. Example: a developer creating a media player uses the Windows 7 Programmer Interface (APIs) to play audio, access files, and display video. The programmer doesn't need to write low-level code for controlling the sound card or graphics hardware. The interface handles it. Key takeaway. Think of the programmer interface as a remote control for Windows 7. It lets developers use pre-built buttons, functions, and libraries to control the system, making software development faster, easier, and safer. Next unit 5. Long questions. First important long question is: 1. Explain the design principles of the Linux operating system in detail. Design principles of the Linux operating system. Linux is a powerful, open-source operating system widely used in desktops, servers, and embedded devices. Its design is based on several important principles that make it stable, flexible, and efficient. 1. Simplicity and modularity. Linux is built in a modular way, meaning it has a small core, kernel, and optional modules that can be added when needed. Example: device drivers, like for a printer or USB, can be loaded as kernel modules without restarting the system. 2. Portability. Linux is designed to run on different types of hardware. The code is written in C, which makes it easier to adapt to new machines. Example: Linux runs on PCs, smartphones, Android, and even supercomputers. 3. Multi-user and multitasking. Multiple users can use the system at the same time, and it can run many processes simultaneously. Example: on a Linux server, one user can run a database, while another runs a web server. 4. Hierarchical file system. Linux organizes files in a tree-like structure, making it easy to locate, store, and manage data. 5. Security and permissions. Linux uses user accounts and permissions to protect files and processes. Only authorized users can access sensitive data. Example: only root, administrator, can install software or modify system files. 6. Open source and community-driven. Linux allows anyone to view, modify, and distribute code. This leads to continuous improvement and innovation. 7. Networking capabilities. Linux has built-in network support for connecting computers, sharing files, and running servers efficiently. 8. Stability and reliability. Linux is known for long uptime and minimal crashes, making it ideal for servers and critical applications. Key takeaway. Think of Linux as a smart building with flexible rooms. Each module or component can be added, removed, or upgraded without disturbing the whole system. Its design principles make it secure, efficient, portable, and reliable, suitable for both beginners and professionals. Next important long question is: 2. Discuss Linux process management and scheduling with examples. Linux process management and scheduling. Process management in Linux involves creating, executing, and terminating processes while ensuring that the system resources like CPU, memory, and I/O are used efficiently. A process is simply a program in execution. Linux uses a process table in memory to keep track of all running processes. 1. Process creation and termination. New processes are created using the fork system call, which duplicates a parent process. The executive system call can replace the process's memory with a new program. Processes terminate using exit, freeing resources. Example: when you open a browser on Linux, the shell process creates a new process for the browser using fork and executive. 2. Process states. A Linux process can be in one of these states: running, currently using the CPU; waiting, blocked, waiting for I/O or an event; ready, waiting for CPU allocation; zombie, finished execution but still in process table. 3. Scheduling in Linux. Scheduling decides which process gets CPU next. Linux uses different scheduling algorithms to ensure fairness and efficiency. 1. First come, first served. FCFS processes are executed in the order they arrive. 2. Round robin, RR. Each process gets a fixed time slice, quantum, in turns. 3. Priority scheduling. Processes with higher priority get CPU first. 4. Completely fair scheduler. CFS, modern Linux scheduler that balances CPU time fairly among processes. Example: on a Linux server, a web server process, high priority, gets CPU faster than a background backup process, low priority, ensuring fast response to users. Key takeaway: Linux process management and scheduling ensure that multiple programs run smoothly, resources are used efficiently, and users experience minimal delays. Think of it like a restaurant kitchen. Orders, processes are managed, prepared, and served efficiently according to priority and timing. Next important long question is: 3. Write a detailed note on Linux memory management and file system structure. Linux memory management and file system structure. Linux is designed to manage memory efficiently and organize files in a structured way for fast access, security, and reliability. 1. Linux memory management. Linux uses memory in a flexible and dynamic way to ensure all processes get the resources they need. Virtual memory. Each process sees its own memory space, called virtual memory, which is mapped to physical memory, RAM. This prevents one process from interfering with another. Paging and swapping. Linux divides memory into pages. If RAM is full, some pages can be moved to disk, swap space, and retrieved later. Memory allocation. The kernel allocates memory dynamically when programs request it using mechanisms like malloc. Cache and buffers. Linux uses part of memory to cache frequently used data, improving speed. Example: a web browser may use virtual memory for multiple tabs, ensuring each tab runs independently without crashing others. 2. Linux file system structure. Linux organizes files in a hierarchical directory tree, starting from the root directory. Important directories include bin, essential binaries, commands like ls, cp, etc., configuration files; home, user directories; var, variable data like logs. TMP temporary files. Dev device files, printers, USB drives. Linux supports multiple file systems like Extension 4, XFS, and BTRFS, each offering features like journaling, security, and reliability. Example, when you save a document in Home Ali Documents, Linux uses the file system to store it safely on the disk, keeping track of its location, permissions, and ownership. Key takeaway. Think of Linux memory management as a smart library. Each reader, process, gets their own table, virtual memory. Books can be temporarily moved to storage, swap. And frequently read books are kept on top, cache. The file system acts like a well-organized library directory, making it easy to find, access, and manage all files. Next important long question is: 4. Explain the design principles and system components of Windows 7. Design principles and system components of Windows 7. Windows 7 is a user-friendly, stable, and secure operating system designed to run efficiently on desktops and laptops. Its design and components ensure smooth operation, multitasking, and easy interaction between hardware, software, and users. Design principles of Windows 7. 1. User-centric interface. Windows 7 emphasizes an intuitive GUI with features like the Start menu, taskbar, arrow interface, and easy navigation. Example, jump lists and thumbnails allow users to quickly access recent files. 2. Compatibility. Supports a wide range of hardware, software, and drivers, ensuring smooth operation across devices. 3. Reliability and security. Uses features like Windows Defender, User Account Control, UAC, and Windows Update to protect data and system integrity. 4. Performance optimization. Efficient memory management, faster boot times, and support for multi-core processors enhance overall performance. 5. Networking and collaboration. Built-in networking features allow easy sharing of files, printers, and internet access. System components of Windows 7. 1. Kernel. Core of the OS that manages memory, processes, hardware interaction, and system calls. 2. User interface, UI. Provides a graphical interface for users to interact with applications and system settings. 3. File system. Organizes and manages files using NTFS, supports security, permissions, and large storage. 4. Device drivers. Software components that allow the OS to communicate with hardware like printers, graphics cards, and USB devices. 5. System libraries, DLLs. Pre-built functions and routines that programs use for tasks like file handling and network communication. 6. Utilities and applications. Tools like Control Panel, Task Manager, and Windows Media Player help manage, monitor, and use the system efficiently. Key takeaway. Think of Windows 7 as a well-organized office. The kernel is the manager coordinating tasks. The user interface is the receptionist helping visitors. Device drivers are specialized staff for equipment, and system libraries are manuals for employees. Together, they make the OS efficient, secure, and user-friendly. Next important long question is: 5. Compare Linux and Windows 7 operating systems in terms of architecture, process management, and security. Comparison of Linux and Windows 7 operating systems. Linux and Windows 7 are two widely used operating systems, but they differ in architecture, process management, and security. 1. Architecture. Linux uses a monolithic kernel with modular design. Modules, like device drivers, can be added or removed without restarting. It is highly portable, running on PCs, servers, and smartphones. Windows 7 uses a hybrid kernel, combining features of monolithic and microkernel designs. It emphasizes user-friendly interface and compatibility with a wide range of hardware. Example, Linux can run on servers with minimal hardware, while Windows 7 focuses on desktop user experience with GUI tools. 2. Process management. Linux supports multi-user and multitasking with process states like running, ready, waiting, and zombie. Scheduling uses completely fair scheduler, CFS, priority-based, or round-robin methods. Processes are created using fork and executed with executive. Windows 7 also supports multi-user multitasking. Processes are managed using threads and jobs. Scheduling uses preemptive priority-based methods, giving high-priority tasks faster CPU access. Example, on Linux, a web server and database can run simultaneously without interference. On Windows 7, running Word and a media player is managed efficiently using preemptive scheduling. 3. Security. Linux uses user accounts, permissions, and groups for file and process security. Root access is required for system changes. Open source nature allows transparency and quick fixes. Windows 7 provides user account control, UAC, Windows Defender, firewalls, and regular updates to protect the system. Security is built for ease of use, especially for non-technical users. Example, on Linux, only root can modify system files. On Windows 7, UAC prompts users before installing new software. Key takeaway. Linux, flexible, secure, efficient, ideal for servers and programming. Windows 7, user-friendly, compatible, visually appealing, ideal for desktops. Think of it as Linux is equal to a robust engine for heavy tasks, and Windows 7 is equal to a comfortable car for daily use. Both are powerful but serve different needs.